Hey guys, this is Christine from 1301. Today I'm just going to be doing a quick video showing some strategies on how to convert binary, hex, and decimal numbers to each other and back. So the first thing you need to know about binary and hexadecimal numbers are that binary numbers are base 2 and hexadecimal numbers are base 16. So the numbers that you're probably more familiar with are decimal numbers, and decimal numbers are base 10. So what that means is, for example, if you have a number like 476, each one of these numbers is going to represent a different power of 10. So 6 is obviously 10 to the power of 0 times 6 is 6. And then 70 is 10 to the power of 1 times 7 is 70. And then 400 is 10 to the power of 2 times 4, which is 400. And then all of these added together give you 476. So when you think about it that way, binary and hexadecimal numbers are not really that different. So for today's video, let's just go ahead and fill out the following table. Let me get rid of that. So let's do something like this: hex, decimal, and binary. And then what we can do is we can start out with 197 as a decimal number and 10110110 as our binary number. So our goal for this video is going to be to fill out the remaining 4 slots in this table. Okay, so let's start out with converting 197 to binary. So I think it's easiest to convert a decimal number to binary and then binary to hexadecimal. That's just my preference. So let's go ahead and let's start out with 197 down here, and then let's set out 8 little slots for our binary number, okay? And so we know that this place is going to be the ones place: 2, 4, 8, 16, 32, 64, and 128. So the first thing we need to do is we need to figure out which is the biggest power of 2 that can go into 197. So we can see here that it's 128. So we'll put a 1 here, and then we'll see what the remainder is after we subtract 128. So we get 69, and then we see of the remaining numbers, which is the greatest power of 2 that goes into 69. So we can see here that it's 64, so we'll put a 1 here and then subtract 64. So now we have 5 remaining. Now we can see that 32, 16, and 8, they're all too big to go into 5, so we can put zeros. And then we can see that we can put 1, 4, and 1, 1 in and put a 0 in the 2's place. So this is the binary number we get, so we can go ahead and fill that out. I'm going to put it in blue to differentiate from the rest of the numbers. So this is our answer. So from there, it's really easy to convert to hexadecimal, because what you can do is you can take each of these blocks of 4 and take them as their own hexadecimal number and then combine the results. So what I mean by that is take 1100. So 1100 base 2 is equal to 12 base 10. So I mainly say that just so it's easier for us to convert to hexadecimal. So you guys remember that when we get past 9 in hexadecimal, they become numbers. So I'm just going to write out what all these numbers are. Okay, so we go from A to F, 10 to 15. So we can see that 12 base 10 is going to equal C in hexadecimal. So that's C base 16. All right, so we know that this chunk is going to be C, and then we can do the same thing here. So this is 5 base 16. And so when we combine these two, we get C5, and that's going to be our hexadecimal number. So that's just a quick way. If you don't want to convert from decimal to hexadecimal, because I feel like that can be a little bit tedious, what you can do is you can just convert it to binary and then convert it to hex, which I find easier. Okay, so now we figured out how to convert a decimal number to both hex and binary. So now let's figure out how to convert a binary number to decimal and hex. Okay, so we've already talked about how to convert a binary number to hex. So let's just go ahead and do that really quickly. We'll do that down here. Oops. Okay, so our number is 10110110. So again, we can just go ahead and convert those. So 1011, that's going to equal, what is that, 11. So this is 11 base 16, and that's equal to, oh, sorry. This is 11 base 10, so that's equal to b base 16. And then this is 6 base 16. So when we combine them, we get b6. Really easy. So let's fill out our chart here. Okay, so the last thing to do is convert binary to decimal. So you can try to convert hexadecimal to decimal or binary to decimal. Either one is fine. Let's just go ahead and, for the sake of this example, we'll do binary to decimal. So keep in mind, I'm going to write the values for each of these binary slots on top. So there's 1, 2, 4, 8, 16, 32, 64, 128. Okay, so all of the ones are the values that we're going to add up. Okay, so we know that we need to add up 128. We don't need to add a 64 because there's a 0 there. We're going to add 32. We're going to add 16, a 4, and a 2. Okay? Oops. So let's go ahead and add all of that. We have, let's see, some quick math. 22, and then 8. Okay, so we get 182 by adding all of these spots that have 1s in them. Okay? So we're going to put, oops. We're just going to put a 182 here. Okay, so as you can see, this is our finished table. So I know this video was short, but hopefully you learned a couple of strategies from for converting from one type to another. My last advice is just, if you want more practice in number conversion, just go ahead and think up some numbers for yourself, and then try to convert them into all of the other types, and then go online to hexadecimal to decimal to binary calculator website and check your answers there. And that's, I think, the easiest way to get practice. All right, thanks for watching. Bye.